Okay, in this video, I'm going to go over the first page of the test review test. So problems 1 through 7, and then there'll be a separate video for the other problems. Okay, so let's start with number 1 here. This is for topic 1. So for number 1, we have to compare these two numbers that are being given here, the cubed root of 64 and 8/3. And in order to compare them, we've got to change the way that they currently are written. So the cubed root of 64 is going to be a positive 4, because we know that 4 times 4 times 4 will equal to 64. And for 8 over 3, we have to change that improper fraction to a mixed number. We know that 3, we can get 2 groups of 3 out of 8. So 3 goes into 8 2 times, which would be equal to 6. And so my mixed number, the whole number is going to be 2. And then from 8 to 6, that's 2 left over. That's my numerator. And 3, the denominator, stays the same. So when you're looking at those, in order to compare them, we just can compare the 4 to the 2, and you know that the 4 is larger, and so that's why this is the correct answer. For number 2, you're simply choosing which of these numbers are rational or irrational. And so we know that when we see a fraction, 49 divided by 5, it's negative. It doesn't matter if it's negative or positive. It's a fraction. We're going to label that as rational. The square root of 100, which we know equals to 10. So that is going to be a rational number. The square root of 7 is irrational because it is a non-perfect square. Then we have a repeating decimal here, 11. 0.59 repeating decimals are rational numbers, and the square root of 200 is irrational. It is again a non-perfect square. Okay, so for number 3, we're being asked to choose the list of numbers that is already in order from least to greatest, so from the smallest value to the largest value. So before you even start calculating anything, there's a few things that will help us to eliminate some possible answers. So for instance, we're shown pi in a few different places, and I'll write it here. And remember that pi, we approximate the value of pi as 3.14. So if I take a look at this first one, I see that 3.15 is here and pi, which is 3.14, is there. I know that that's not in order, so I'm not even going to bother calculating those. This cannot be an answer. If I take a look at B, which right now you know it's the answer, but when you're taking the test, you'll take a look at B and you see, okay, pi is 3.14. Then this next value begins with a 4. This one begins with a 5. This will be one that we would come back to and then verify that the square root of 27 and the square root of 32, which they are, would be in order. For the letter C, what would throw us off here before we do any calculations? What could we look at? Well, we've got here the square root of 19 is a number that comes before the square root of 12. That wouldn't make any sense. And again, pi, which is 3.14, should not be before 3.0. So that tells me that this cannot be a possible answer. I won't even bother trying it. Then again, we have here on the process of elimination, you can take a look. And just the fact that I see a 4.3 that's listed before pi, which would be 3.14, that tells me that that won't be it. So then that just leaves me making sure that this one is in order. Pi is 3.14. We've got 4.3 repeating. Here we've got 5.1, and the square root of 27 has to come before the square root of 32. So that tells me that B is the correct answer. All right, now up to number 4. For number 4, we're just selecting all of the irrational numbers. And so remember, irrational numbers are going to be non-perfect squares and non-perfect cubes. pi, and any decimals that never end and never repeat. So if we take a look here, we know that the square root of 17 is not a perfect square. This would be in between square root of 16, square root of 25. So that tells us it's irrational. Square root of 50, same thing. It's a non-perfect square. It'd be after the square root of 49. So that's irrational. And pi is listed as irrational. When we take a look at the other options, we know that this is equal to 10. Negative 1/10, well, it's in fraction form and it can be written as a decimal or a fraction. So that's rational. Remember, all rational numbers can be written as a fraction. And so negative 1/10 is a fraction. And 2 and 5/10, well, that can definitely be written as a fraction as and 2 and 5/10, which can be written as 2 and 1/2. So those are the only three options of irrational numbers. Okay, so now let's take a look at number 5. So for number 5, says here that the expression 4 times. So remember that we're looking at 4 times the square root of 169 gives the perimeter of the square that's shown. What is the perimeter in meters of the square? So first, let's simplify this, and then we'll come and take a look and make sure we understand the difference when we see perimeter and we see area. And so the multiplication that we have to do is first we have to find the square root of 169. And so we know that the square root of 169 is going to be 13. And so here the multiplication then we're going to have is 4 times 13. And that's going to give us 52. So 4 times 13 is going to equal 52. And they're asking what the perimeter would be. So it is important to know the difference between area and perimeter. When they're asking us for the perimeter, they're asking us just for the outside measurement. So think of perimeter as a fence. If you're putting up a fence, you need to measure the actual sides of this square. And so we're being told in the problem that it's 4 times the square root of 169, which means that each of these sides are 13. 4 times 13 is what gave us this answer of 52. Because if I do 13 plus 13 plus 13 plus 13, or 13 times 4, that's measuring each side of this square, and that's how I get the perimeter. Okay. For number 6, we're being asked to solve the equation x squared equals 26. Remember, when we're dealing with a square root, we should have two answers, the positive and the negative root. And so that's why for letter A, we have this positive and negative root. And we're giving this answer as an exact answer. Remember, when we're solving these problems, that in order to solve it, we're going to have to take the square root of each side, and that will cancel out both the square and the square root symbol. X is alone on that side, and that's going to equal the positive and negative root of 26. So we're going to give it as an exact answer, stating that it is the square root of 26, because if we simplify it down to try to find the closest decimal, we'll be approximating an answer. It won't be an exact answer. For number 7, we're being asked which expression of these was going to have the greatest value. Okay, so in order to be able to do this, you're going to have to approximate these irrational numbers. You can do them more roughly, not as precisely as we've been doing them in class, in order to just to see which has the greatest value. So for instance, for the letter A, we're doing a multiplication of 2 times the square root of 14. So the square root of 14, we want to remember that the square root of 14 would be somewhere between the square root of 16 and the square root of 9, much closer to 16 than to 9. So it's going to be between 3 and 4, closer to 4. Okay? So if I were to roughly estimate this, this would be 2 times 4, which could equal about 8. And it's not an exact, it's about 8. If I were estimating B, well, we have the square root of 28 minus 4. So the square root of 28, what square root could I use that'll be close to that? Well, 28 would be between the square root of 25 and the square root of 36. So we're looking at a number between 5 and 6. So if I did 6 minus 4, I would get 2. If I did 5 minus 4, either way, I would get a 1. So this one is going to simplify down to either a 1 or 2. If I used even the larger number, it still won't be larger than A. So I know this is not going to be an answer. If I got 8 for A, that's greater than either 1 or 2, so I can eliminate B. We know C is going to be the answer, so I'll get to that one in a second. But let's take a look at how we could, in our minds, get a good value for D. So the square root of 27, again, we're looking at a number that's really close to the square root of 25. So let's just estimate this to be approximately 5. It's a little bit more than 5, but close to 5. And this one would be 3. So this is also going to give me 8, okay? So now, if my only choices were A and D, I would have to further approximate them to see where it's going to go. But let's see what C gives us. And then when you're doing the test, you could see if C would give you a better response. And then if it didn't, then you would have to simplify these two further. Okay, so for the square root of 70, well, that's really close to the square root of 64, which would be an 8. So it's going to be more than 8, but I'm going to use an 8. And then plus the square root of 36 is 6. Altogether, these have to be way more than any of the other ones. 8 plus 6 is going to give me a 14. This has to be the largest one by a lot. So I don't need to mess with the other numbers at all.